Ciao friends! In this video we will see how to optimize the inventory calculation based on snapshot tables. We will see how to create these snapshot tables if you don't have ones, but we will also see how to mix calculations that leverage the existing snapshot table with the transactions to obtain the inventory amount for dates for which you don't have the inventory available. We will see several demos, several benchmarks, so let's start with the demo. Our scenario is based on two transaction tables. We have the classic sales table in Contoso by product, customer, date, and store. But we have a second table that contains the amount of products sent to the store over time. So Contoso is this fictitious company that sells goods using brick and mortar store in a chain of brick and mortar stores, and we want to know the amount, the inventory amount in quantity and money that we have in each store over time, and also the total amount for all the stores over time. However, we don't have an inventory amount, an inventory quantity already available. We have to compute this amount by using the transactions we have in sales and supplies. So let's take a look at the example we have. So this is the final report we want to obtain. We want to obtain a report where we can see the quantity and the amount corresponding to the quantity over time. We can have this evaluation made by year, month, or even by day. And this is the part that requires a more complex calculation and a performance issue that we want to solve later. A classic example actually is not this visualization, but this visualization is one of the examples I want to test for the performances. The second one is the line chart. You see that this is called slow. Actually, it didn't take time, but just because I executed this report before starting the recording, I didn't want to wait 1 minute to see this visualization. But we will see how to measure the benchmark for different reports with different amount of data. I will explain this later. So you imagine that when you see this chart, you realize that there are many data points. Actually, we are using a line chart where we have one data point for each day, which is particularly expensive, probably not a good idea, but we want to see how far we can go to optimize this kind of calculation. Now, what is the model we have? So let's take a look at the data models. Actually, the data model is one, but I split the data model into parts because you see that here we have the sales table and the supplies table, two fact tables that are connected to product, that is the same product table, to date, the same date table, and to store, the same store table. So basically we have, in supplies supplies is this table, supplies has the transactions of the amount sent to each store. And usually we have a shipment every week, every 2 weeks, or maybe during the week, but we can expect that the number of transactions we have for each store is smaller than the number of transactions we have for the sales table. The sales table, so the store, for example, receive a quantity of 50 for a product, but then the sales are 1 product, 2 products, 3 products, and so the number of transactions is bigger for sales for the same number of products in stores. We can represent that with this kind of visualization. And the idea, what we want to express here, is that the density of the information is bigger in the sales table. So the sales table has more transactions. You see that here we have more, the area, let me highlight this area. The area we have in this timeline is more dense. We have more transactions for sales compared to what we have in supplies, which is the other table here. So in supplies, we can expect there are days where there are no transactions. This is expected. And the reason why I'm showing you this is because what is the required effort in order to compute the quantity on hold for each day? Where if you think about the calculation, so the calculation we can see in DAX, so let's go back to the report and let's take a look at the quantity on hold measure. The quantity on hold measure is the DAX code that basically subtract the amount of quantity from the sales table from the quantity amount from the supplies table. But for each given date, it has to sum all the transactions that happened from the beginning of the history up to that date. So we stop this calculation on the last day visible in the filter context. So you can imagine that for each data point, for each point in the line chart that we have seen before, we have to compute what? Well, for this data point, for example, this point here, let's see if I can draw this. So if you consider this data point, what we have to do, we have to compute the sum of all the previous transactions, the sum of the quantity for sales, the sum of the quantity for supplies minus the sum of the quantity for sales. We can represent that with this other visualization, which basically shows the formula that I just described in the line chart. And the thing is that every time you consider a different data point, you have to consider this calculation again from the beginning. The way we compute this calculation is always from the beginning, because in DAX, we cannot rely on the calculation of the previous day. I know that this is what we would like to do, so every day we get the value of the previous day, but the way DAX works cannot use this system when you create a measure in the model. There are techniques to do that in visual calculation, but this is not something that we can use in the model. And so we have to figure out how to optimize the calculation once we publish the report for any kind of visualization. Now, an important role, of course, is the data volume. And how can we check the data volume? The data volume is something we can check with DAX Studio, for example. If I open DAX Studio connected to this model, you can see, if I go in advanced view metrics, that we have this cardinality. The cardinality is the number of rows we have in each table. And in this case, let's ignore these two tables. These are the tables that I want to create. I already created here, but the tables that we want to consider at the moment are sales, supplies, and then of course the cardinality of the dimensions, customer, store, product, and date. So we will consider different versions of the same model with different amount of rows, because sometimes the performance issue could be not so visible if you consider a small model, but the larger the model, the bigger the performance issue could be. And so in order to evaluate how each approach could benefit our calculation, we compare different versions of the model. Let's say if I have the numbers here. So this is the number of rows we have in the table. Now, the model I'm showing now at the beginning is the 100K, this model here. 100K means more or less 100,000 transaction orders in the sales table, but we have version with just 10,000 orders, 1 million orders, 10 million orders. And when we go at 10 million orders level, you see that the sales and supplies tables are much bigger, whereas the number of date, product, and stores, these numbers don't change. We only have a smaller number of dates in the 10K version, which is only with 3 years of data, whereas the other models, the other examples here, from 100K to 10 million, we have 10 years of data. And of course, 10 years of data means that when we sum the previous 10 years, we have to sum a larger amount of data. So this is the initial scenario where we want to perform our calculation. So what is the current performance that we have in our calculation? Well, first of all, we can, I can go back to this visualization, for example, this report. What we can do, we can click on Optimize, Performance Analyzer, Start Recording, Refresh Visual, and we can capture the query executed. Let's take a look at this query in the query view. We can take a look at this query, and we can basically execute this query several times. However, in order to simplify the benchmark, we try to simplify the calculation a little bit, and we also wanted to evaluate different scenarios. For example, if we take a look at the initial model, so when you look at the model here, you see that sales and supplies basically share the same dimensions, but customer, right? Customer is the only dimension that is not shared, because customer is only shared for sale. We know the customer to which we sold something, but actually for the quantity on hold, we can ignore the problem, because we are not interested into the customer. We will never compute the inventory by customer. So considering the store and the product and date, well, the cardinality of the calculations could be big. So we will see that at a certain point, we might want to try to optimize the calculation without filtering the store. So basically, we want to optimize the calculation just by product and date, but then we want to also analyze what happens if we filter one or more stores. Because of course, pre-calculating data also by store will increase the data volume of our snapshot table, something that I will introduce in a moment. So for this reason, we created a few benchmark queries, starting from the query that we see for the matrix, because the query that we see in the matrix has the characteristic of having different granularities. So this query has data at the year level, at the month level, at the day level. Whereas when we take a look at the line chart is actually simpler, I would say, because we have in the line chart one value for each day, but the number of data points we have to compute is much bigger. And that's the reason why we want to, you see that this is still running. I extracted the query here, and I prepared a simpler query to execute. So let's take a look at the queries that we have. So this is the query that we prepared for the calculation corresponding to the matrix. And basically what we have here, to simulate the filter by store, we will introduce a filter by store. We will see this later. And here we will analyze two measures. The measure that computes the quantity on hold, and also the evaluation of the amount on hold that in reality is based on the quantity on hold. If we take a look at the measure amount on hold, we can see that the only difference is that for each product unit cost, we multiply all the products that have the same unit cost by the quantity on hold of all those products in the current filter context. So this is the calculation that we will test later. And of course, you can realize that this calculation will depend on the number of unique product unit costs we have. This is already an optimization compared to iterating all the products, because we can group all the products that have the same unit cost. So this is now you see that we finally have the line chart, and the query we have for the line chart. Let's see if I have the query available. It should be here. So these are the queries for the line chart. So for the line chart, we have these two versions of the query, the line chart slow and line chart optimized, that we will see later. So at the moment, we didn't create the optimized version. I already prepared here. And you see that the execution of this query basically provides one value for each date, whereas the other query that we were testing, the one for the matrix, has values at the year level, at the month level, and at the day level. So probably we have a lower number of rows here with the matrix, but a more complex calculation because we go at different level of granularities. So the challenge is the following. First of all, do we need to optimize this calculation? Well, I executed these benchmark before starting the recording, and so I can share the timing that we have. So we can make a few considerations. So the timing for the 10K is actually not something that we are concerned about, because we have 57 milliseconds, the time is milliseconds, for the matrix, regardless of filtering by store or not. But when we consider the line chart, we already have more than 1 second. And remember, we are considering a relatively small amount of data. Now, as soon as we go to 100K, which is the model I was showing now, you see that the line chart starts to be very slow. And you notice that when I clicked on the line chart, when Power BI didn't reuse the previous query in cache, it took almost 1 minute. We are at 46, 47 seconds, whereas the query of the matrix is still below the second. However, if we move up to 1 million of orders and 10 million of orders, now you see that with 10 million of orders, we have almost 8 seconds to wait for the matrix. I'm not going to show you this, but actually you can test the same query. If you reproduce the problem, you can test the same query with DAX Studio. You will find in the article all the links and instruction to create such a big data model. And the time for the line chart is 11 minutes. Yes, it takes so much to execute that query. So we want to reduce this timing. And in order to reduce this timing, we have to figure out how to pre-calculate something, because just optimizing DAX without pre-calculating something is not enough. Pre-calculating data means that we need to create additional tables where we pre-calculate the quantity on hold at a given date, potentially for each date. But we will see that computing the calculation for each day could be very expensive, could be more expensive than the original tables with the transactions. If you can afford it, it's probably the best way. But the idea is that we want to see how we can mix a snapshot we compute, for example, for each end of the month, with the ability to compute the calculation at the day level, but taking advantage of the existing snapshot so that we reduce the window of data, the window of transactions that we have to compute to calculate the quantity on hold for any date. So let's take a look at the from a conceptual point of view, what we want to do. So when I say I want to create an inventory snapshot, I mean, if we start considering sales and supplies, the tables that we considered before, that have a certain density, a certain granularity of the calculation, we had transaction for every day, and we have a very high density for the sales table. If I create a snapshot every end of the month, for example, I will see only one day, the last day of the month, in the snapshot table. But of course, because I have to store for that day, the end of the month, I have to store the value of the inventory for each product, and potentially for each store. If I want to go at the store level, I always have a certain amount of transaction, even though we didn't have a movement, we didn't have sales for that product in that store for the entire month. It doesn't matter. We have to create the row in the inventory table every time. And this means that the inventory table could grow a lot, especially if you have a lot of products or a lot of stores, because you have to potentially get the Cartesian product of all these combinations, or at least those combinations that have at least one or more products available in the inventory. So the question is, so once we have this inventory, it will be very simple to compute the inventory at the end of each month, because it will be just the sum of those quantities for that day. But the question is, how do we create this table? Because the assumption is that if we only have the transactions tables, we don't have the inventory available, so we have to compute it. Now, we have many options, and probably if you are able to compute this inventory table before importing the data in Power BI or in tabular model in general, is better. It's better because you can have a logic like an incremental calculation. You only compute the last month, for example. The solution I'm going to show you in this example is not based on that, because that will mean finding some solution in SQL or Fabric or Power Query, and so there are many options there. We don't want to explore all of them. It depends on your particular architecture. One option we have is to use DAX. I'm not suggesting you to use DAX all the times, because every time you open the report, every time you refresh any part of the model, the calculated table has to be computed again. And also when you apply changes to the model, for example, when you edit a measure, that calculated table is computed again. It could slow down the editing experience unless you use tabular editor, for example. So the calculated table I'm going to show you is just one example we can use. Is the example we can use for a relatively small model, but if you already have 10 million orders, the 10 million table, it will be very slow. If you use the 10K, the smaller model, you will not notice any problem, but as soon as the model grows, it could be a performance issue. The time to refresh the model, then the query time will be optimal, like you import the data from an external source, but you have to consider that someone has to pay the price, the processing time, and the memory to compute the snapshot table. So let's take a look at the calculation of this snapshot table. So first of all, from a data modeling standpoint, what we're going to do is this. So we're going to create an inventory store table where we have, for each end of the month date and for each store and product, we have the value of the quantity on hold, this one. And of course, this quantity on hold must be computed, if we're using DAX, using the measure that we have seen before, the quantity on hold, the slow measure we have seen before, because someone has to pay the price. Now, you can imagine this table, this inventory store table, could become very, very large. And my headquarter might be interested in knowing the inventory amount for the entire network of stores without going at the level of each store. So because the size of this table could be relatively large, one idea could be, why not creating another snapshot table, we call this inventory global, where we have only the combination of product and date, but we don't include the store, meaning we want to compute all the stores. Now, you will see that for this particular example, it could be not so relevant, but trust me, when you have a complex model, you have, for example, many stores, you might want to have this second option. And one interesting point is how to manage the automatic use of the right table in our measure so that the user doesn't have to know what is going behind the scene when it just queried the model without worrying about which tables are involved in the calculations. So let's prepare both. And so let's start with the inventory store table. The inventory store table is the table, let's see if I can see it, is the table that basically produces this. For each product, for each store, for each day, only for the last day of the month, the quantity on hold. And of course, we create this row only for the products and store for which at that day there is at least one as a quantity on hold. How do we compute this? Well, basically we start from the intersection of all the combinations of end of the month, product key, and store key. So in the date table, we already have a column end of month, so it's easy to get only the end of the month for the relevant months we have. For this Cartesian product, we compute the quantity on hold amount. So we duplicated the code of the DAX measure, just because this way we could fix a few things. For example, it's important to use the all no blank row to avoid a circular dependency. If we use the measure, we would not have been able to have this kind of control. So this way we can obtain a result in a calculate table that then we can connect to the existing dimensions. And of course, at the end, we ignore those combinations that have quantity equal to 0, because if it is 0, I can just skip the row, and the assumption is that if there is no quantity on hold record in the inventory table, the quantity is 0. So we just at the end, we just rename the column so that we obtain exactly the names that we want, and the inventory global is basically the same approach, with just the difference that we can, for example, leverage the inventory store. So instead of computing the calculation again from the beginning, from the transactions, if we already computed the inventory store, we can just aggregate the inventory store table into the inventory global table. Now, what is the cost for creating these inventory tables? We can see the number of rows that we created in the inventory store and inventory global table. And when you look at the size of the 10K model, you see that the size is bigger than the size of sales and supplies, because we start with a small number of transactions. There is not much density. We have many products, and there are many combination of months, product, and store for which we didn't have any transaction, but we have to repeat the inventory. The more data we have, so 100K, 1 million, and 10 million, with 10 million orders, you see that with 10 million orders, the number of rows at the store level is 8 million, whereas we have 21 million transactions in sales and 6 million of transactions in supplies. So if we had a very dense sales table, we probably have a much smaller inventory table, because the problem is understanding how many cases, in how many cases we have a row in inventory for combinations that don't exist, but at the same time, because we have one row per month, it also depends on how many transactions on average we have for each combination. So the bigger, the more dense and bigger the transaction table, the smaller the inventory table, and the opposite is true. So the inventory table could be expensive, but sometimes it could be not so expensive as the transaction table. Other times is much bigger than the transaction table. It depends on your model. So it makes sense that you consider evaluating these numbers, because these numbers tells you whether you can afford a granularity of the inventory, not at the month level, but at the week level, at the day level, or something like that, or at the quarter level if it is too expensive. So this is the first step. The second step at this point is that, okay, can we already use the inventory amount? Yes, because for example, if I consider this report where I have the quantity on hold computed using the transactions, I could get the value, for example, from the inventory store. So let's create a measure here, quantity. And in this measure quantity, I want to compute the sum of the quantity on hold for the inventory store table. And you see that this time working on it is because I'm creating a measure, but the Power BI is calculating the calculated tables. So this is very, very slow. The user experience is not good. That's the reason why I try to prepare most of the measures. But I just want to show that if I want to compute the quantity here, quantity store snapshot, I just want to do something like a calculate, where I want to sum the quantity on hold in the inventory store table, but I don't want to aggregate all the months in a period. I want just to get the last month in a year, or the last day of the month for a month. And so the last date function does exactly what I need. So date, I want to get the last day in the current filter context, and I want to compute this calculation. So now, if I commit this measure and wait for the refresh for the calculated tables, you see that the calculated tables are not ideal for this kind of approach. We already have problems with 100K. You can imagine what happens when you have 10 million or 1 million. So my suggestion is to start with a very small model and then refresh the model with using a connection to a bigger database. But now that we have this store snapshot available, if I include a store snapshot here, you see that we have the amount. So let's try to fix the format. Hopefully it doesn't have to refresh everything. Okay, so the numbers is correct, but you should notice that, let's say if I can get rid of this, how can I do this? Okay, if I look at the numbers, everything is working at the year level, at the month level, but if I go at the day level, I don't see the data. I don't see the data because we don't have the value for the 1st or the 2nd of April and so on. Of course, when I go at the last day of April, I have the value available. So the calculation is correct, but the calculation does not provide the right number at the day level. And so this could be also the case where you have, for example, the snapshot at the quarter level, and then you want to compute the value at the month level. So we have to introduce something to get the value also at the day level, taking advantage of the existing snapshot so to reduce the query time. How do we compute the inventory at the day level by taking advantage of the existing snapshot? First of all, let's review the algorithm that we want to implement from a conceptual point of view, and then we take a look at the DAX code to implement that algorithm. So the starting point is that we have these snapshots. So the snapshots we have are at the end of each month. And let's say that we want to compute a value in a certain data point. For example, imagine we go to this day in April. So in order to compute this value, what we have to do is to get, okay, we can start from this value March, but then you have to consider only the transactions that occurred after the 31st of March for both the supplies and the sales tables. So in other words, I have a better design representation of that. What we want to do is the following. So we want to consider only this snapshot and only these transactions that correspond to this range. So we want to sum the inventory amount at the end of the March at the end of March. Then we want to sum the supplies transaction, so how much increase in quantity we had, and then we want to subtract the sum of the sales happened from the 1st to the 20th of April if we're computing the value for the 20th of April, so this date. But this process has to be repeated for every day. Anyway, so how do we translate this into the DAX code? So for the inventory store table, we created a quantity on hold that is for the store table, for the inventory store table, where first of all, we retrieve the last day of the filter contest. For example, if we are looking at the 20th of April, this will be the 20th of April. Then we have to know what is the last date with the snapshot. Now, we could assume is the previous month, but if I want to create a measure that automatically adapts to what is the snapshot available, then I want to retrieve the last date available in the snapshot table before less than or equal to the last day that I have in the filter contest, which is exactly what we do here. Last inventory date is the last date in the inventory store table that has some data before that is less than or equal to the reporting date, the date for the report. And pay attention, we remove the filter because we want to ignore whether we have a filter for a particular store or a particular product. We don't care. We want to get, okay, what is the last date for each? There is a snapshot. Because remember, if we know that for that date, the last day of the month, there is a snapshot, but we don't find a transaction for a particular combination of product and store, it means that the value is 0. So we have to actually filter that date. Now that we have this date, that is the date for the inventory, first we get the sum of the quantity on hold for that date. Why we sum? Because we could have multiple stores, multiple products. Depending on the filter content, we want to sum the inventory amount, the inventory quantity for that date only. And this is the value for the 30th of March. But then we want to also compute the transactions happen in sales and supplies in the range after the 30th of March until the 20th of April, for the 20th of April. Which means that we want to filter the date that is greater than last inventory date, less than or equal to reporting date. And we sum size quantity, we subtract the sum of sales quantity of the sum of sales quantity, and we retrieve the last transactions quantity. The inventory amount is the sum of the last inventory quantity plus the last transaction quantity. So this is the implementation in DAX of the algorithm that we described in the previous calculation, in the previous example with the whiteboard. Is it working? Is it faster? Well, we have to test it. So in order to do some benchmark, what we did, I used DAX Studio, and for example, I have in this example, I show you the test with the matrix. I'm going to use the version with 10 million rows, the biggest one, but only in this one, this execution makes sense. So now I'm going to try the existing measure that we consider slow. And if I run this test, let's see what happens. I enable the server timings. I think is a few seconds that requires to execute this report without using the snapshot. So this is the original execution time that I also shown you in an initial slide. I focus my attention on the line chart that was I think 11 minutes. But as you see, also this case is slow. And you see that it took 8 seconds, actually more than 7 seconds. Probably there is some variance every time we execute it. But this is the slow version of the calculation. Now, in order to test the fastest version, so I'm going to comment these two measures, and I'm going to use these other measures that are the ones optimized. So basically, the calculation that I've shown you now, that is the optimized one. This is not exactly the same, but internally it is calling the measure that I've shown you. So I run this test, of course, after we clear the cache, and we see what happens. But you see that the improvement is amazing, because we went from 8 seconds to 200 milliseconds. Now, I already made the tests for different calculations, so we can see the execution time here that so this was the initial execution time for matrix and line chart. And when we look at the improvement, so we have seen the improvement for the matrix live, but for the line chart, because this takes many minutes, I can show you that the improvement, the performance improvement for the line chart is 71 times, because we are able to run the line chart for 10 years in 9 seconds, which is still a lot, but is much faster, is 71 times faster than the original one. You can go to 0, you can go to 1 second, but you should create one snapshot for every day. Probably by creating a snapshot every week, we could down from 9 seconds to maybe 2-3 seconds. But again, it's always a question to balance the performances with the cost for creating the snapshot and to store the snapshot. So it's always something that you have to evaluate. I'm showing the extreme situation to enable you to make a decision about what you want to do. Probably what makes sense is if we don't need to see the inventory day by day, I want to see it by week or by month, I will adapt the inventory granularity to what I want. Or if I want to go at the day level, I accept that it is lower, because most of the reports are at the month level, but only when I go to at the day level, thanks to my dynamic calculation in DAX, I use the snapshot, but then I sum the transaction only for the window of time that is needed. We have already seen how to optimize the calculation for one inventory table. But if you remember, we created 2 inventory tables, because in some scenarios, we might want to have a smaller inventory table for the more frequent calculations and a larger one, a bigger one, when we go at a higher level of detail. But this higher level of detail might involve a very big table that could be, let's say, not optimal to be queried. Now, this is not the case for our example. So what I'm going to show you does not produce a different significant performances for the queries that we test, but the principle could be valid in different scenarios. Let me try to clear what I mean. So if we consider the number of rows we have in the snapshot tables, we have, for the inventory store table, we have 8 million rows in the bigger model, the 10 million orders, and we have 1 order of magnitude of difference, a smaller table, 10 times smaller, more than 10 times smaller, in the inventory global table. Which means that if my query doesn't filter the store, I might just want to use the inventory global table, for example. And now I didn't show you all the tests in the videos, but in the article you will see all the tests made with the store, without the store, with one table, with another table. You will see that the performance difference is minimal for this case, because in this case, even though we have a 1 order of magnitude of difference between the 2 inventory tables, in reality, the bigger one is still a small table. So from a storage engine point of view, doesn't matter. But if you realize that the storage engine cost to access the inventory table is significant and you want to optimize it, then having the 2 inventory tables or more could be an effective way to manage the performance improvement. But at that point, how can we avoid the user to be faced with the choice of which snapshot you want to use? The user doesn't have to know that these snapshots exist. So what we can do, we can create a measure that, based on the filter context, chooses which inventory table to use. So for example, in our case, let's see the quantity on hold optimize the calculation. So the idea is that we have 2 measures below, one for the inventory global and one for inventory store. These are the 2 optimizer measures we have. So one for this model, I could choose between the 2 by saying, well, if there is a filter active in the store table, then I have to use the quantity on hold with the inventory store. Why? Again, let's take a look at the data model. So if we take a look at the data model, you remember that this is the situation of our transaction tables, and the store table, the store table is in both. But then when we created the snapshot tables, we used the store table only for the inventory store table here. So the inventory store is connected to the store table. When can I use the inventory global, which is smaller? When there are no filters affecting the store table here. So let's see if I can highlight this. So if there is a filter on store, then I want to use the inventory store table. But this is because I know the model. And what if I want to create a measure that automatically adapts to the data model? So the idea is that because we consider what are the dimensions that are common. So for example, oh sorry, I made a mistake. So if I consider date is here and is here, let's use another color, and let's see this one, and product is here and here. So the idea is that as long as I have filters applied to dimensions that are common to the fact tables, to the snapshot tables, it's fine. They are compatible. But as soon as I have a filter on a table that exists in one table and not in the other, then I had to use the table that has that filter. How can we generalize this regardless of the changes we could make in the future to the data model? So what we can do, we can test this same cross filter, but in a different way. We can use a check on the fact that the snapshot table that has that bigger detail, the inventory store in this case, but let's say the more detailed snapshot, is it filtered if we remove the filters from all the dimensions that are also connected to the table, in this case inventory global, the one that has a smaller number of rows? What does it mean? It means that we want to check whether there is a filter active on some table that is not in the inventory global, in the table that is smaller. So the pattern that you can use at this point is this. We want to calculate whether there is a cross filter not on the store table, but on the table that has the bigger detail, so the inventory store table. Once we remove the filter from the global inventory global table, because the calculate, when we affect the filter content, we remove the filter from the expanded table, we remove the filter from the inventory global and all the tables connected with many-to-one relationship. So from product, from date, and from anything else. So in the future, any change to the model will be automatically applied to this calculation. And this is a more generic technique to retrieve the value that we want with the right granularity. And so this is the calculation that we actually used for our test. So if I take a look at the final result for the matrix that I mentioned before but didn't show you, so the matrix is optimized by using this technique that depending on the granularity uses or does not use one table or another, because you might have a certain point in the matrix you can drill down at the store level and only for those calculations you want to actually use the inventory store table, otherwise you can use the inventory global table. And you see that in this specific case, the advantage is 42 times, going from almost 8 seconds, because the test we made, it was probably on a faster computer, and we go down to 187 milliseconds. And this is the kind of advantage we have by using both. So we didn't notice particular differences for this example between using inventory global, inventory store, but I know that with larger model, you might notice a difference, especially in the storage engine calculation between the two versions. You will notice that in this case, most of the time is spent not in the storage engine, but in the formula engine for computing the transactions between the snapshot, the last snapshot available, and the date that you analyze. But when you have a very large inventory table, tens of millions of rows or more, you might notice a difference going, for example, from 200, 300 million rows to a table that has only a few million rows. We have seen that you can improve the performance of inventory calculation by using snapshots. We have seen how to create these snapshots tables in DAX, but remember, it's better to create these snapshots tables before importing the data in a Power BI or analysis services model. This is because the calculate table could take a while to be computed, and it affects the performances also of your editing experience, especially if you use Power BI Desktop. Then we have seen how to combine the calculation available in the snapshot table, the numbers available in the snapshot table with the transactions we have, because if we have a snapshot every month and we want to compute the inventory available for each day of a month, then you have to sum the last snapshot available, the last inventory available, with the transactions that occurred during the days of the month. And this is a balance that provides the maximum ability to analyze the data at the day level without paying the price of computing all the transactions from the beginning of the history, but trying to optimize the presence of a snapshot table, not for every day because it could be too expensive, but for example, we have seen starting from the last month available, even though you can choose whether to use the month, the week, or the quarter as a granularity for your snapshot table, because we try to create DAX code that automatically adapts to the available granularity in your snapshot table. And we have also seen how to optimize the access to multiple snapshot tables that could have different granularities. As usual, enjoy DAX!